Hello and welcome. In this lesson, we will study the set of real numbers and the algebraic operations on it. At the beginning, there are various sets of numbers, like the set of natural numbers n. It is defined as it starts from 1 to infinity, and it is infinite set. Contains on the positive integers numbers, and it not contains on the fractions or decimals. And if we add 0 to it, we will give it the symbol n0. That is, the union of the set of natural numbers with 0. The second set is the set z of all integers. It can be represented as it is infinite set, which includes the positive integers, the negative integers, and 0. And the set n of natural numbers is a subset of z. The third set is the set of rational numbers. It can be represented as, that is, the set of numbers that can be expressed as the quotient of two integers, where the denominator is not 0. And the sets n and z are subsets of the set of rational numbers. The fourth set is the set of irrational numbers. It can be represented as, that is, the set of numbers that cannot be expressed as a simple fraction. They have non-repeating, non-terminating decimal expansions, like the square root of 2, and pi constant, and Euler number. The set of lesson of today is the set of real numbers R. It can be represented as the union of the two sets, the set of rational numbers, and the set of irrational numbers. And the sets n and z and q are subsets of the set of real numbers R. And the set of real numbers R is a subset of the set of complex numbers C. The set of complex numbers or imaginary numbers can be represented as follows. That is, for any two real numbers x and y, the complex number is expressed in the form of x plus iy, where I is the imaginary unit. It is equal to the square root of -1. There are two fundamental algebraic operations on the set of real numbers R: the addition and multiplication. These operations obey to some laws. The first law is the closure for addition. The set R is closed with respect to the addition. That is, for any two real numbers, a and b, then a plus b is a unique real number. For example, 1 and 9 belongs to R. And 1 plus 9 is 10, and 10 is also belongs to R. The second law is the associative law of addition. The operation of addition in R is associative. That is, for any three real numbers, a, b and c, a plus b plus c is equal to a plus b plus c. For example, 2 plus 3 is 5, and 5 plus 4 is 9. This is equivalent to 4 plus 3 is 7, and 7 plus 2 is 9. The third law is identity element for addition. There exists an identity element, 0, such that, for all a, in R, a plus 0 equals 0 plus a. For example, 6 plus 0 equals 0 plus 6. The fourth law is existence of negatives. For every real number a, there exists an additive inverse, is called negative of a, such that a plus negative a is equal to 0. For example, 3 plus -3 is equal to 0. The fifth law is a commutative law. For each pair of real numbers, a and b, a plus b is equal to b plus a. For example, 4 plus 5 equals 5 plus 4. And the first law of multiplication is the closure for multiplication. The set R is closed with respect to multiplication. That is, for any two real numbers, a and b, then a times b is a unique real number. For example, 3 and 7 belongs to R, and 3 times 7 is 21, and 21 is also, belongs to R. The second law is, the associative law of multiplication. The operation of multiplication in R, is associative. That is, for any three real numbers, A, B and C, A times, B times C, is equal to A times B, times C. For example, 2 times 3 is 6, and 6 times 4 is 24. And this is equivalent to, 4 times 3 is 12, and 12 times 2 is 24. The third law is, the identity element for multiplication. There exists an identity element, 1, such that, for all A in R, A times 1 equals 1 times A. For example, 4 times 1 equals 1 times 4. The fourth law is, existence of inverse. For every real number A, there exists an inverse of A, such that A times 1 over A, is equal to 1. For example, 5 times 1 over 5, is equal to 1. The fifth law is, the commutative law of multiplication. For each pair of real numbers, A and B, A times B, equals, B times A. For example, 4 plus 5 equals, 5 plus 4. The sixth law is, distributivity of multiplication, over addition. The multiplication distributes itself over addition. That is, for any three real numbers, A, B and C, A times B plus C, is equal to, A times B, plus A times C. For example, 4 times 2 plus 3, equals, 4 times 2, plus 4 times 3. Then, we can say that, the real numbers, form a field, with respect to addition and multiplication. The familiar examples are the field Q of all rational numbers, and the field C of all complex numbers. And finally, the subtraction and division in R. The operations of subtraction and division in R, can be defined, in terms of the operations of addition and multiplication. The difference between two real numbers, A and B, is given by A plus negative B, is denoted by A minus B. For example, 9 plus negative 5, is denoted by 9 minus 5. And for the operation of division, the quotient of a real number A, by another B, which is not equal to 0, is given by A times the inverse of B. It is denoted by A, over B. For example, 3 times the inverse of 2, is denoted by 3 over 2. Now, our lesson of today is finished. See you later in the following lesson.